talked about classifying quadrilaterals. So these first 5 questions are just testing that knowledge. The best way to go about these is find the definition or remember the definition for the two things and then figure out does the first one fit inside the definition of the second one. So for example, a rhombus is a quadrilateral with 4 congruent sides. A rectangle is a quadrilateral with 4 congruent angles. So a rhombus could conceivably have or not have all 4 congruent angles. So a rhombus is not going to fit the definition of a rectangle all the time. So this is false. A rhombus is not a rectangle. A square is a rhombus, though. Well, a square has 4 congruent sides and 4 congruent angles. A rhombus has 4 congruent sides. So yeah, a square is, every time you have a square, it's going to have to be a rhombus because it has those 4 congruent sides. A trapezoid is a parallelogram. A trapezoid has 1 pair of parallel sides. A parallelogram has 2 pairs of parallel sides. So there's no overlap between those two. So that's going to have to be false. Trapezoid is trapezoid. Parallelogram is parallelogram. Nothing to do. A rectangle is a parallelogram. That's true if you look at the definition. The definition of a rectangle is a parallelogram that has 4 congruent angles. A square is a parallelogram. Well, that's going to have to be true because number 4 is true. Because a square is a rectangle because it has the 4 congruent angles and 4 right angles. So since a rectangle is a parallelogram, well, the square is a rectangle and a rectangle is a parallelogram. The square is going to have to be a parallelogram. To find area, just remember that area is base times height. So in this case, it is 6 times 10, which is 60. And that'll come into play later in this lesson, which is all about figuring out, can I calculate the length of a diagonal, which I'll tell you what that is, and can we calculate heights and parallelograms so that we can find their areas. Okay. So a diagonal is a segment that connects opposite angles. Okay. So, for example, if I have my parallelogram here, this is a diagonal. Okay. So notice that in a quadrilateral, there's 2 diagonals. There's one that goes from these 2 opposite angles, and then there's one that goes between these 2 opposite angles. Alright, so this is the fun part. If I want to find the length of the diagonal AC, and I know it's a rectangle because of all these right angles, well, notice that in this rectangle, since I have right angles, I have these lovely right triangles going on there. And we know something about the sides of right triangles. We know that if we take a right triangle and we know 2 of its sides, we can find the third one using our Pythagorean theorem. So a squared plus b squared equals c squared. In this case, my a and b are 4 and 3 because those are the legs because they're on each side of my right angle. So that gives me 4 squared plus 3 squared equals c squared. So that is 16 plus 9 equals c squared. That would be 25 equals c squared. Don't forget that to get rid of the squared, you take the square root. Well, it happens to be that the square root of 25 comes out even, so c is equal to 5. So the length of my diagonal in this case is 5. I will ask for 2 different ways to write the answer. I'll ask for the I'll ask for the exact answer, which is just the simplified radical. So if square root of 25 hadn't come out even, then I would have had to simplify the radical like we did in the last unit. As there was no simplified radical, so we'll just call it 5. The approximate is whenever you go ahead and type it into your calculator, you find the decimal, and then you give it to me. I'll usually ask for a rounded like in two decimal places. Okay. In this case, your exact and your approximate are the same. But in this case, okay, we've got a lovely rectangle again, and this time we're going to concentrate on this right triangle in here. So if I'm setting up my Pythagorean theorem, it would be 6 squared plus 10 squared equals c squared, because c is still my diagonal that I want. So that would be 36 plus 100 plus c squared. So c squared equals 136. You take the square root of both sides. So the square root of 136. Now I think there are some numbers that will come out of 136. And 4 is one of them. 4 times 34. So to get the exact answer, the simplified radical, I'm going to need to break this into the square root of 4 times the square root of 34, which is 2 times the square root of 34. So that is my exact answer. For my approximate answer, I typed into my calculator, is the square root of 136. And that gives you 11. Okay, so I've got this right triangle again. This time I'm not given both of my legs. I'm given my hypotenuse, which is one of my legs. So it's going to be x squared plus 7x squared equals 15 squared. So this will be x squared plus 49 equals 25. Doesn't make this 15 squared. Yep. And then we'll have to subtract 49 from each side. So I'm going to say x squared equals 176. Square root of that. Alright, so exact answer, I'm going to have to simplify the square root of 176. And let's see here. I think 16 and 11. Yeah. So break into the square root of 16 times the square root of 11. So the square root of 16 is 4. 4 over 11. So that is my exact. Okay. My approximate, I just put into my calculator the square root of 176. And that tells me that is 13.26. Okay. Alright, now for calculating heights. Okay, so to find the area of a rectangle, we did base times height. Well, it turns out for a parallelogram, it's the same thing, but you gotta be careful about where your base and your height are. Because your base is these sides here, these base sides. But your height is actually that line that is perpendicular to the base. So this is your height. So this is not your height over here. This is. Okay? So we're going to need to be able to find this segment in order to find the area of a parallelogram. Now we could use the Pythagorean theorem. In this case, if we're given this side right here. So luckily we are. So to set up to find my height, I'm going to have to do 4 squared plus x squared equals 9 squared, because these two are my legs. This is my hypotenuse. So this gives me 16 plus x squared equals 81. So here, 81 minus 16. So x squared equals 65. So x equals the square root of 65. And for these, don't worry about getting an exact answer. Approximate is fine. So if I plug that into my calculator, that gives me 8.06. So on and so forth. I just cut it off right there. So my height is 8.06. So now I can find the area of my parallelogram. So give me 14. That's 8.06. Okay. So this is 12.87 for my area. So same idea for this one. Okay, so go ahead and try this on your own, and then I'll work through it. So we call that x. This will be 2 squared plus x squared equals 6 squared. So that'll be 4 plus x squared equals 20, or I'm sorry, 36. So the x squared equals 32. So x equals the square root of 32. I know you can simplify that, but just go ahead and find the approximation. So that will be 5.66. Okay. Now that I have my height and my base, I will go ahead and go over here and calculate my area. So that's going to be 56.6. But this is why we learned special triangles in the last chapter, because sometimes we run into things where we aren't given that nice little thing right here. It would be awesome if we had a way to still find the height. So if you remember our special right triangles, we had a 30, 60, 90 triangle. The short leg was 1, long leg was square root of 3, the hypotenuse was 2. Okay. So in this case, my hypotenuse is 12. So to get from my hypotenuse to my short leg, I had to divide by 2. So this is 26. to get from my short leg to my long leg, I had to multiply by the square root of 3. So my height is 6 root 3, which if I plug that into my calculator, it's going to be 10.39. Okay. Now I have my height, so all I got to do is multiply this together. This should give me my area, which is 187.06. So that's the area of this parallelogram. Okay. So kind of similar idea here, except for this time this 30, 60, 90 is on the side. So this is actually my short leg. So if this is my short leg, all I have to do to get from my hypotenuse